My name is Rachel, and I'll be talking to you today about a subtle shift from a fourth grade classroom that including a cross-cutting concept of cause and effect relationships in the context of a lesson.
What did you do?
This is an example of a subtle shift in response to how a lesson went. The shift was to add a mini lesson on the cross-cutting concept of cause and effect, and to apply this thinking to helping students analyze data. This particular lesson actually had two shifts. Today we're going to focus on the cross-cutting concept shift, but the lesson also included adding the practice of modeling, which we will discuss in a separate video. I'll explain the original lesson in a little bit more detail in a moment. I just wanted to set the context for this shift, which was that students were having trouble with the making meaning part of the lesson. They could not analyze and interpret this graph, which is showing that the greater the distance between two magnets, the weaker the force between them. We thought that using the cross-cutting concept of cause and effect relationships might help the students make sense of their data. In prior lessons, the kids had explored magnets. They'd seen that they attract and repel and had seen them interact with other materials. The students saw that there's a push or a pull to the magnet. This lesson is supposed to help them see that there's a strength to that push or pull that gets weaker with distance. You can see here on the slide a picture of the setup, which involved an equal arm balance with two cups. There was a magnet on the post on the left-hand side, and then inside the plastic cup was another magnet that was attracted to the magnet on the post. The students would then place washers one at a time in the cup on the right side until they were able to separate the cups so they broke the force. In each subsequent trial, a plastic spacer is put on top of the magnet on a post in order to separate the two magnets. As you add spacers, you separate the distance between the two magnets. And each time the students record the number of washers it takes to break the force. Each group got a set of 6 sticky dots in a different color, and they were supposed to plot their data on a class chart with their sticky dots so that the teacher could discuss the data with the class as a whole. Now, up until this point, the lesson was completed exactly as written in the original FOSS guide. The original lesson has a short discussion of about 5 minutes where the students are supposed to see that the farther apart the magnets are, the weaker the force between them. The teacher, however, found that the students were confused by the data, and only 1 or 2 seemed to get that there was a relationship. We told the students that one way they can make sense of the things that they observe is to think about what caused those things to happen. We call this a cause and effect relationship when an action causes something else to happen. For example, if I were to kick a ball, it would roll down a field. I used this example to introduce a sentence frame, blank, so blank, as a way to express the relationship. With the ball example, what we did was to kick the ball, and what happened was that it rolled down the field. I then walked over to the light switch in the room and said, I turned off the lights as I turned off the lights, so, and the students replied in choral response, it got dark. I held up a marker and said, I let go of the marker, so, and as I released the marker, the students repeated, so it fell down. We then started a science talk where we asked the students to think about cause and effect relationships in terms of what they observed or did in the breaking the force activity. It worked really well to use a T-chart to record their responses as cause and effect relationships. Sometimes students would start with what happened or what they observed, and I would prompt them to say what they had done before they observed that effect. So I might fill out the effect column first with their example and then push them to figure out what did they do before that happened to cause it. Also, the students brought in evidence from prior lessons. For example, magnets connecting when they were close, or a magnet falling down to the ground when it was far away from the top magnet. Logistically, it worked really well to use different colors for each cause and effect relationship so that the kids could easily track each cause and effect connection. We discovered during this talk that because the relationship was not linear, the students found it confusing. They saw a big effect at the beginning of their experiment, 5 or 4 washers difference between each banana chip, that tapered off after the magnets were a certain distance apart, when only 1 less washer or even no washers were needed to break the force. But when we referred back to our cause and effect chart, there was consensus that there still was a relationship, even if it was strongest when the magnets were closest and tapered off as the magnets became farther apart. I think that this lesson worked particularly well because in any lesson where there are correlated variables, you're going to be looking at a cause and effect relationship. So for example, if the students had been exploring parachutes and testing different parachutes, they could use a cause and effect relationship to see that the heavier weight will cause the parachute to go faster, or a bigger shroud might cause the parachute to go slower. Or with an earth science example, if they're exploring stream tables that are set up with a large number of blocks, they'll see more erosion. Or if they use a big flow hole in their water cup, they'll see more erosion. What I found from trying out this subtle shift was that using the cross-cutting concept of cause and effect relationship is a useful tool for the practice of analyzing data. Once you've introduced a mini lesson, and our mini lesson was really simple, you can refer back to, a SO sentence scaffold and use a T-chart to cue the kids into this kind of thinking. While the students, after this part of the lesson, were able to see that there was a relationship between the distance between 2 magnets and their magnetic force as a result of this mini lesson, it's actually not the end of the story. There were other questions that the students brought up where we addressed by using the science and engineering practice of modeling. And I'll give an example for that in a later video. So in conclusion, this idea of taking an existing lesson and adding a subtle shift to make it more aligned with the next generation science standards is something that is an easy way to go about incorporating next generation science standards in your classroom.